In this lesson, we'll be solving problems involving right triangles. So from our previous lesson of working with the primary trigonometric ratios, we are hopefully ready to solve problems involving right triangles. Before we solve some of these problems, though, I wanted to talk about two math terms which will be used when we work with these problems. So we have angle of elevation and angle of depression. Okay, so for angle of elevation, we're talking about the angle from the horizontal upward to an object. Okay, so if this was an individual and their line of sight, the horizontal would be here. Okay, and if they want to look at this window, let's say, this is the angle of elevation. Okay, it's relative to the horizontal. A very common mistake would be to draw the angle of elevation relative to the vertical, but by definition, the angle of elevation is with respect to the horizontal. And if we have angle of elevation, we can also say the angle of depression. So if someone was looking out of the window, this is the horizontal, and this is the angle of depression. Once again, the angle of depression is measured from the horizontal downward. Okay, so angle of elevation measures upward from the horizontal, and angle of depression measures down from the horizontal. Now this is very useful because when we read the word problem, we want to draw the diagram correctly. So please always draw the angle relative to the horizontal when we're talking about angle of elevation or angle of depression. Okay, so you know what? Let's try some word problems. Okay, from a point 36 meters from the base of the tree trunk, the angle of elevation to the top of the tree is 24 degrees. Find the height of the tree to the nearest tenth of a meter. Okay, so I'm just going to draw the tree. And with all trees in math, we're going to assume that it's perfectly vertical. Okay, so let's say this is the point here, and that's to the top. Okay, so you know what? What I really want to get out of this is the right triangle. So I'm going to draw the right triangle that is useful for this. So this is the height of the tree. Okay, you can say here, that is the height of the tree. This angle of elevation is 24 degrees. So we're really talking about the interior angle here is 24 degrees. And we know that it's 36 meters from the base. Oh, actually. Okay, so this is 36 meters here. And yep, so we want to find the height of the tree to the nearest tenth of a meter. So let's label the sides. Well, let's do it in our heads. I think we've got enough practice from the previous lesson, but if you want to write them out, you can as well. So if this is the acute angle that's given to us, this one we are working with, okay, this is the opposite side, and this is the adjacent side, and of course, the longest side is the hypotenuse. So let's see, I have the adjacent side. I'm trying to solve for the opposite side. So hopefully we can agree it's not so, not ka, but it's toa. Okay, so the two sides involved are opposite and adjacent for this right triangle. So we're going to use a tan ratio. Tan 24 degrees is equal to opposite over adjacent. Okay, so the calculator will tell me what tan 24 degrees is. It must be equivalent to this ratio of h over 36, which will then allow me to solve for h. H is equal to 36 times tan 24 degrees. So we're looking at about 16.0. Therefore, the height of tree is approximately 16.0 meters. Okay, All right, let's see what we have here. An airplane is flying at a height of 2 kilometers above the ground. The distance along the ground from the airplane to the airport is 50 kilometers. What is the angle of depression from the airplane to the airport? So once again, just draw the diagram. So I'm not going to bother drawing the airplane. I'm just going to draw the right triangle that I'm interested in to solve this problem. So we have the airplane here. Okay, the angle of depression. I don't know what the angle of depression is. We're going to find out. Let's say this is the airport. Okay, so it's flying at a height of 2 kilometers. And obviously I'm not drawing the scale. And this is 50 kilometers. Because it says the distance along the ground. Okay, now since this is parallel, it's basically you have a rectangle here. So this length along the ground is the same distance as it is in the air, that horizontal distance in the air. Okay, so the horizontal distance in the air is 50 kilometers because the distance along the ground from the airplane to the airport is 50 kilometers. They want the angle of depression. So remember, angle of depression is with respect to the horizontal. So right here, let's call that theta. So now to solve for theta, we want to ask ourselves, which ratio should we work with? Sine, cosine, or tan? So let's look at this. If this is the angle I'm trying to solve for, okay, because angle of depression is with respect to the horizontal, downward from the horizontal. So opposite, adjacent, hypotenuse. Hey, I think we're looking at the tan ratio again. And if you have the ratio, your calculator can solve for the angle. So inverse tan of 2 over 50. So I'm going to round it to like 1 decimal place. Okay, about 2.3 degrees. The angle of depression is approximately, 2.3 degrees. Okay. Haley and Alex are facing each other on opposite sides of a 20-meter tree. I'm going to say it's 20-meter tall tree. Haley sees the top of the tree at an angle of elevation of 49 degrees. Alex sees the top of the tree at an angle of elevation of 35 degrees. How far apart are Haley and Alex? Okay. So I drew it a little poorly on purpose because I actually want you to figure out who is closer to the tree. Is Haley closer to the tree or is Alex closer to the tree? As Haley was 49 degrees and Alex is 35 degrees angle of elevation. So remember, angle of elevation is upward from the horizontal, okay? So you're really looking at this and this. So the answer you're looking for is the sum of x and y, because that will tell you how far apart are Haley and Alex. So to answer a question earlier, who is closer to the tree? Well, who has to tilt their head higher? Right? Haley has to tilt her head higher. So if that's the case, that should mean she is closer to the tree. Okay. So let's do the math. Let's find out how far apart are Haley and Alex. So x plus y. Okay, let's solve for x and y individually. Okay, and then we'll do x plus y. So if we solve for x, which ratio are we using here? Okay, let's cover this triangle for solve for x. Hopefully you can see opposite and adjacent again. Oh, tan again? Alright, so tan 49 degrees is equal to 20 over x. So which means x is 20 over tan 49 degrees. Alright, what about y? Well, if you cover the left triangle, we're looking at opposite over adjacent again. So tan 35 degrees is equal to 20 over y. So y is 20 over tan 35 degrees. So you know what? X plus y is equal to about 45.9. So therefore, Haley and Alex are approximately 45.9 meters apart. Just out of curiosity, how far is Haley from the tree? About 17.4. And Alex is 28. So, like I said earlier, because Alex has to tilt his head, well, Haley has to tilt her head higher, so she has to be closer, assuming they're the same height. Yeah. So that is this is called a double right triangle problem because you have two right triangles. Okay, so for the next example here, Brody's bedroom window. From Brody's bedroom window, he sees the top of a building at an angle of elevation of 47 degrees. He also sees the bottom of the building at an angle of depression of 18 degrees. If he measures the horizontal distance between his house and the building to be 55 meters, what is the height of the building? Okay, so let's see. This is Brody's bedroom window. Okay, he sees another, I'll draw it. It's just, hopefully it's not that bad. Let's see. Okay, so he sees the top of the building. He sees the bottom of the building. Okay, and this is how far the buildings are apart. Okay, so the angle of elevation is 47. Angle of depression is 18. And we said that the two buildings are 55 meters apart. So how high is the building? Well, we need to solve for this and this. Okay, so once again, we have the double right triangle. And unfortunately, if you look at it, you're looking at the tan ratio 2 times again. Because if I cover that, I have the opposite and adjacent. Well, I'm solving for the opposite side and I have the adjacent side. And if I look at the bottom right triangle, I am trying to solve the opposite side and have the adjacent side. So tan 47 degrees, and so let's say this is H. Okay, so tan 47 degrees, opposite over adjacent, y over 55. And y is 55 tan 47 degrees. And then for the triangle at the bottom, for angle of depression is 18 degrees. X over 55. So x is equal to 55 tan 18 degrees. Okay, so if the height of the building is x plus y, then the height of the building is 55 tan 47. So about 76.9. Okay, so therefore height of building is approximately 76.9 meters. All right, last one. Tiffany and Natalie are both looking up at the CN Tower, at top of the CN Tower. Tiffany's angle of elevation is 36 degrees. Natalie's angle of elevation is 64 degrees. If the CN Tower is 553 meters, if the CN Tower is 553 meters, I should say high, how far apart are the two girls? So let's see. Okay, let's draw the diagram. So now we have to answer the question, who's closer? Is Tiffany closer or Natalie closer? So if Natalie's angle of elevation is 64 degrees and Tiffany's is 36, then we know that Natalie is closer. And Tiffany is here. So this is 553. Okay, so what we want to do, if we want to see how far apart are the girls, you want to solve for how far is Tiffany from the base, let's call that X, and let's say how far Natalie is from the base, let's call that Y. How far is Tiffany from Natalie? Just by finding the difference of X and Y. Okay, so let's solve for X and Y. Which ratio? Oh no, tan again. It's because it's opposite and adjacent. So let's do X first. So tan of 36 degrees is equal to 553 over X. So X is 553 over tan 36 degrees. What about Y here? So tan 64 degrees is 553 over Y. So Y is 553 over tan 64 degrees. So the difference between X and Y, that will tell me how far apart the two girls are. So looking at about 491.4 meters. Therefore, the girls are approximately 491.4 meters apart. Okay, so unfortunately for this handout, we did a lot of tan ratios, but in the homework, you will see that you don't always use a tan ratio, okay? But one thing I wanted to mention is that for some of the questions, we actually gave you the diagram. And for all the ones we did, for the 5 examples we did together, we don't have a diagram. So of course, if you don't have the diagram, you have to provide yourself the diagram. Okay, just take your time, interpret the problem, and remember the definition of angle of elevation and angle of depression.